Alright, you are all welcome to the next class. Today we'll be talking about biochemistry and we'll be looking at the chemistry of carbohydrates. So carbohydrates, hydrates of carbon. So today we'll be looking at the isomerisms in carbohydrates. In our last class we look at the carbohydrates, we look at the overview of carbohydrates. We said what is carbohydrates? We say carbohydrates are hydrates of carbons. We said there are polyhydroxyaldehydes or ketones, and then or compounds that yield them on hydrolysis. So we also say that carbohydrates could be made up of either monomers to polymers. And then we said the monomeric part of it are called the monosaccharides, and when these monosaccharides are two monosaccharides are linked together, they are called disaccharides. And these disaccharides, when monosaccharides of 3 to 10 are linked together, they are called the oligosaccharides, and when they are more than 10, they are called the polysaccharides. The polysaccharides are joined together to what? Condensation reaction, while the disaccharides to the oligosaccharides are joined together by the polypeptide bond, so we call it glycosidic bond. So they are joined together by the glycosidic bond. So these are what we look at in the last class. So today we'll be looking at the isomerism. We also look at the structure of carbohydrates. We look at the aldose and the fructose. We say the one that have aldehyde functional group is called the aldose. The one that have fructose functional group is called the fructose. And then we also look at how the type of structure that carbohydrates have. We talk about the Fischer projection structure, and we also talk about the Howard projection structure. So today now we'll be looking at the isomerism in carbohydrate. What are the type of isomerism in carbohydrate? But first of all, what is isomerism? Isomerism is a condition or phenomenon whereby compounds having the same molecular formula have different structural formula. So now let's see how isomerism occur in carbohydrates. Now, the first carbohydrates generally undergo only one type of isomerism, which is optical isomerism. Isomerism is divided into different parts. We have structural isomerism, we have geometric structural isomerism, we have geometric isomerism, and then we have optical isomerism. So in our own, we are going to be looking at the optical isomerism. So the type of optical isomerism that carbohydrates undergo include the D and L isomerism, the epimerism, the anomerism, and the enantiomers. These are the four that it undergo. Although in further DCH there are up to 7, but that will be at master level. But at this our own level, we'll be looking at just these 4. So now let's start with the D and L isomerism. D and L isomerism. The D and L isomerism, the D simply means dextro-rotation and L means levo-rotation. So now let's take a compound of glucose. We love using glucose as an example. So let's say we have a carbon. Let's start with 3 carbon atom, which is glyceraldehyde. So now, looking at this, these are two compounds. Okay, these are similar compounds. So looking at these two compounds, if you look at the OH here, at the penultimate carbon, the penultimate carbon is always the second to the last carbon. This is the 1, 2, 3. So the second to the last carbon is this OH, this carbon. So you look at the position of the OH group on this carbon. If the OH is at the right hand side, then it is called a dextro rotation. But if the OH is rotated to the left hand side, it's called a levo rotation. If it is rotated right, it is called dextro rotation. When it is rotated left, it's called levo rotation. So now this one is, the OH is rotated right, therefore it will be called D-glyceraldehyde. D-glyceraldehyde. While this one that is rotated left is called L, because it's rotated left, it is a levo rotation, so you call it L-glyceraldehyde. We call it L-glyceraldehyde. So now let's look at one more example, then before we move to the next one, which is epigenetic. So let's look at the most popular one, which is what? The glucose. We have this 1, 2, 3, 4, 5, 6. Oh shit. Sorry. Please come back again. This place I made a mistake in the structure. It's supposed to be CHO. This place is also supposed to be CHO. Yeah. Sorry for that. So let's come back here. Alright, so now these are another two isomers. These are another two isomers. So these are another two set of isomers. We look at the penultimate carbon, as I said. So now looking at the penultimate carbon, which is the penultimate carbon? I said the second to the last carbon. This is the second to the last carbon. So that's the penultimate carbon. In D and L isomerism, this is the place we always centralize our attention. Now look at this. They only differ in this penultimate carbon. Every other thing is the same, but there is difference in this penultimate carbon. So now what happens? In this first one, it is what? Rotated right, while the second one is rotated left. So in this case, we say this one, we say whenever it is rotated right, it is called a D isomer, and whenever it is rotated left, it is called an L isomer. So now since it is located right, we call it a D isomer. So now therefore this one is going to be D glucose, while this one will be called L glucose, because it's located left, so it will be called L glucose. However, nature has decided to work more with the D glucose than the L glucose. The L glucose is rare in nature, while the D glucose is very common, and that is the one that is why if you want to go and buy glucose, you see they put glucose D, right? That is D glucose. So don't drink L glucose. Hope you understand. So now let's see another type of isomerism, which is known as the Now let us see the next one, which is called Epigenetic. The next one is Epigenetic. Let us see what is Epigenetic. In Epigenetic, I think I will use, okay, let's use Epigenetic as on its own. Let's say we have a glucose. I love using glucose as an example. 1, 2, 3, 4, 5, 6. CH2OH, CHO. Now, compounds having in which there is a rotation in the chiral carbon, there is what we call chiral carbon. 1, 2, 3, 4 are chiral carbons. The middle carbons, apart from the first and the last, all other carbons in the monosaccharides are called chiral carbons. They are chiral centers. So this is chiral carbon 1, chiral carbon 2, chiral carbon 3, chiral carbon 4. So if there is rotation in any of the OH except the penultimate carbon, which is the chiral carbon 4, any rotation in the OH apart from this place is called an epimer. When this one is rotated, it is an epimer. When this one is rotated, it is an epimer. When this one is rotated, it is an epimer. But when this one is rotated, it's called D and L isomerism. And in epimerism, only one is rotated at a time. You don't rotate two at a time. You rotate one at a time. Okay? Unlike we are going to come to another one called enantiomers, you will see where everything will be rotated. But here, we rotate any of the OH apart from the OH on the penultimate carbon. OH on the penultimate carbon, when it is rotated, it is called D and L isomerism. But apart from the penultimate one, any other one out of the chiral carbon that the OH is rotated, then it is called an epimer. So now looking at these two examples here now, look at the two examples. Look at this one, there is no rotation in the first one, there is no rotation in the second one, but in the third one there is rotation. This one is by the left, this one is by the right. And if you go to the fourth one, there is no any rotation. So this shows that there is rotation in chiral center 3, which is not a penultimate carbon. Therefore, these two will be referred to as what? Epimers of one another. These two, 1, 2, are epimers. I can also decide to make another one. Now, look at this one also. Taking a look at this one, we have comparing it to the main compound. This one and this one, they're the same. But in this carbon number 2, there is a rotation. There is a rotation in carbon number 2, carbon number 3, which is chiral center 2. So at chiral center 2, there is what? A rotation. Therefore, this one and this one are also what? Epimers. They are also epimers. So also this one and this one are also epimers. So this is about epimerism. So now we'll look at anomerism. So what anomerism? Anomerism occurs in cyclic carbohydrates. It occurs in cyclic carbohydrates, just as you see these ones occur in fissure projection, but the other one, this one of anomerism, occur in Howard projection. Now let's draw an example. Now, look at these two structures. The first carbon, carbon number 1, this carbon is referred to as anomeric carbon. It's referred to as anomeric carbon. So this carbon is what we use to detect the type of anomaly we are having. So now on this carbon, you look at the OH. You look at the position of the OH. Look at the position of the OH. When the OH is rotated on the anomeric carbon, is rotated down, is called an alpha anomer. While when it is rotated up, is called a beta anomer. So now looking at this one is an alpha anomer, so we can call it alpha D glucopyranose. This is alpha D glucopyranose. We call it pyranose as we explained in the previous lecture about Howard projection. We say the one with 5 carbon ring is referred to as pyran, while the other one with 4 member ring is referred to as furan. So we say this one will be pyranose, while the other one will be furanose. So this one is alpha D glucopyranose because the OH is rotated down. That is why it is alpha. So the compound itself is D-glucopyranose, but the presence of the OH at the lower part is what makes it what? Alpha. So we say alpha D-glucopyranose. While the next one is the OH is rotated up, so we call it beta. So this one will be beta D-glucopyranose. So this is all about anomerism. Just take note of the OH. If the OH is rotated down, it is called alpha anomer. When it is rotated up, it is called beta anomer. Are we together? So now let's go to the last one, which is called the enantiomers. Enantiomers are compounds which are mirror images of one another. What is a mirror? When you look at yourself at the mirror, your hand will be at this side in the when you look at the image inside the mirror, when you are looking at yourself in the mirror, you realize that your right hand will be at the left, while your left hand will be at the right. So there is that inverted image. So in that case, we call that part of with that type of image is the mirror image of yourself. So now we are talking about compounds. The mirror images of compounds are referred to as enantiomers. When two compounds are mirror images of one another, then it is referred to as enantiomers. Let's take an example. I still like using glucose. So this is a glucose. Now, this is a mirror. So the mirror image, in the mirror image, all this OH in the chiral carbons will rotate to the other side, and what is in the left will go to the right, and what is in the right will come back to the left. So let's see what happens. CHO. Here, the OH is at the right, so now we take it to the left. Here, the OH is by the left, we take it to the right. Here, the OH is by the right, we take it to the left. Here, the OH is at the right, we take it to the left also. So these two are mirror images of one another. As you can see, they are mirror images of one another. Therefore, we call them enantiomers. They are enantiomers because they are mirror images of one another. So these are the four types of isomerism that carbohydrates undergo. Now we need to look at the overview. We say D and L isomerism, the rotation is at only the penultimate carbon. Only the penultimate carbon when it is D and L isomerism. When it is rotated right, it is called D isomer. When it's rotated left, it's an L isomer. Epimerism occurs when there is rotation in any of the chiral carbons except the fourth chiral carbon or except the penultimate carbon. Every other place where there is rotation of OH, then it is called an epimer. Epimerism occurs when two isomers differ in what? The position of the OH group in any of the what? Any of the chiral centers except the penultimate carbon. While anomerism occurs when two encyclic compounds, that is Howard projection of carbohydrates and monosaccharides. So it occurs when there is rotation in the anomeric carbon. Anomerism occurs when there is what? Rotation in the anomeric carbon. When it is rotated up, it is called beta anomer. When it is rotated down, it is called alpha anomer. While the enantiomers are compounds that are mirror images of one another. That is, all the OH groups in the right hand side are taken to the left hand side in the second compound, and the H in the right hand side are taken to the left hand side in the second compound. So we will stop here today. May Almighty Allah see us soon. Have a nice day.